Welcome to my presentation. Today we are diving into trigonometry 2. Please like, share and subscribe to support my channel. In this section, we shall consider trigonometric ratios, Roman 1, in terms of coordinates of points for all angles, positive and negative. Roman 2, of angles greater than 90 degrees and also of negative angles using mathematical tables. Roman 3, of all angles, positive and negative, using the calculator. Angles measured in the anticlockwise direction from a fixed horizontal line are taken to be positive, while angles measured in the clockwise direction are taken to be negative. Using a horizontal line QR, angles measured in anti-clockwise direction, and then you have angles measured in clockwise direction. Angles measured in anti-clockwise direction are taken to be positive angles, while angles measured in clockwise direction are taken to be negative. Angle RQP is equal to 30 degrees, while angle RQT is equal to negative 30 degrees. A circle, center 0, 0, radius 1 unit is called the unit circle. The unit here, you can take 1 unit to be 1 centimeter, 1 unit you can take it to be 1 meter, or 1 unit you can take it to be 2 meters, depending on what you want the 1 unit to represent. Otherwise, the smallest can be as small as 1 unit, as small as 1 centimeter. In my case, I can take 1 unit to be 2 centimeters. The unit circle is divided into 4 quadrants, into 4 sectors. We have sector A, sector B, sector C, sector D. These sectors are referred to as quadrants. So A represents the first quadrant, B the second quadrant, C third quadrant, and D the fourth quadrant. Angles are measured using the horizontal line OX, either in a positive, that is the anti-clockwise direction, or from OX clockwise direction, which are negative angles. Using our OX as the horizontal line, we have angles measured in anti-clockwise direction. All these angles are positive. Angle AOB, AOC, AOD, AOE. All these angles are positive because they are measured in anti-clockwise direction. Using our horizontal line OX. Using OX as our horizontal line, measuring angles in clockwise direction will have negative angles. AOE will be negative. AOD will be a negative angle. AOC will be a negative angle. And AOB will be a negative angle because all these angles are measured in a clockwise direction. Trigonometric ratios from the unit circle. We consider the unit circle and the triangle ONA. ONA is a right angle triangle at N, and we have angle theta here. OB is equal to one unit, which is equal to OA, 1 unit, because these are equal to the radius of the circle. ON is the x-coordinate of point A, and NA is the y-coordinate of point A. OA is 1 unit because it is equal to the radius of the circle. Sine theta is always equal to opposite over hypotenuse. So sine of angle theta will be opposite, which is NA, all over the hypotenuse, which is OA. Our NA is the y-coordinate. So sin theta is equals to y-coordinate all over our OA, which is 1 unit. Therefore, sin theta is equals to the y-coordinate. Cosine of angle theta is equals to adjacent over hypotenuse. So it is equals to it's equal to ON over OA. Our ON is the x-coordinate of point A. Therefore, cos theta will be equal to x-coordinate all over 1 unit, because O is the radius of the circle. Therefore, cosine of theta is equal to the x-coordinate. Tan of angle theta is equal to opposite over adjacent. So it is NA all over ON. NA all over ON. Our NA is our y-coordinate of point A. Our ON is the x-coordinate of point A. Therefore, tan theta is equal to y-coordinate over the x-coordinate. Therefore, tan theta is equal to sin theta all over cosine theta, because the y-coordinate is the sin theta and the x-coordinate is the cosine theta. Considering angle AOB as 30 degrees, you get the coordinates of B as 0.86, 0.5. The coordinates of A, 1, 0, because this is a horizontal line, we have the radius as 1, and then 0 goes on the horizontal line. So the coordinates of A are 1, 0. When you move to F, which is a vertical line, AOF, which is 90 degrees, the coordinates of F are 0, 1. Moving further to the angle of 150 degrees, you get at point C, and the x-coordinates are negative 0.86 because this is negative direction, and the y-coordinates 0.5. Move to point G, it is on the horizontal, it is on the x-axis, but on this side it is negative 1 unit, then 0, the y-coordinate is 0, so we have the coordinates as negative 1, 0 for G. When you go to D, which is 210 degrees anti-clockwise, the coordinates of D are negative 8.6, negative 0.86, negative 0.5, because moving this direction it is negative 0.8, then down we have negative 0.5. At H we have, it is the y-axis, so it is 0, negative 1. 0 on the horizontal axis, then vertical axis we have negative 1. When you go to E, horizontally the x coordinates are 0.86, but the y coordinates, because we are going down from the horizontal x-axis, you get negative 0.5. Now we have coordinates. How are we getting these coordinates? Using my diagram, I have taken 1 unit to be 2 centimeters. Therefore, to get, for example, the coordinates negative 8.60, to get the coordinates 0.86, negative 0.5, you move horizontal line, then you go down. So horizontally here we have 0.86, then down, reading from the graph. From the graph we have 0.861, then negative 0.5. To get the coordinates of E. Angle OFE, that is 90 degrees. AOF, 90 degrees. AOG is a horizontal line, 180 degrees. AOH, that is 200, that is 90, 270 degrees. And finally, when you have AOE, it is 330 degrees. At point A, we have 0 degrees and 360 degrees. 0 degrees and 360 degrees. Sine of theta, a sine of 0 is given by the y coordinate. Therefore, the sine of 0 is equal to 0. Cosine of 0 is given by the x coordinate, and at A, our x coordinate is 1. Therefore, the cosine of 0 degrees is 1. Tangent of 0 is equal to sine of 0 divided by the cosine of 0, which is equal to 0 divided by 1, and that one gives us 0. The tangent of 0 degrees is equal to 0. At point B, where we have the coordinates as 0.86, 0.5, we'll get the sine of 30 degrees as the y coordinate, which is 0.5, cosine as the x coordinate, which is 0.86, and the tangent of 30, which is equal to sine all over cosine. So it will be 0.5 all over 0.86. We go to point F. Point F, the angle is 90 degrees because it is AOF, 90 degrees. The coordinates are 0, 1, 0, 1. So the sine of 90, which is given by the y coordinate, which is positive 1. Then the cosine of 90 was given by the x coordinate, which is 0. The tangent of 90 was given by the sine over the cosine, it is 1 over 0, which is equal to infinity. We go to point C. The coordinates of C are negative 0.86, positive 0.5. Therefore, at C, the coordinates are negative 0.86, 0.5, and the angle is AOC, which is 150 degrees. The sine of 150 will be given by the y coordinate, which is 0.5. The cosine of 150 will be given by the x coordinate, which is negative 0.86. Therefore, the tangent of 150 will be given by the sine of 150 all over the cosine of 150. So it will be 0.5 all over negative 0.86. We move to G. G is our horizontal line, and the angle is 180 degrees. And at G, we have the coordinate as negative 1, 0. Therefore, the sine of 180, the sine is given by the y coordinate, so the sine of 180 will be given by 0. The cosine of 180 degrees will be given by the x coordinate, which is negative 1. Therefore, the tangent of 180 will be given by the sine of 180, which is 0, divided by the cosine of 180, which is negative 1, which will give us the answer as 0. At point B, the coordinates are negative 0.86, negative 0.5, and the angle is 210 degrees. Sine of 210 degrees is equal to negative 0.5 because that is the y coordinate. The cosine of 210 degrees is equal to negative 0.86 because that is our x coordinate. Tangent of 210 degrees is equal to negative 0.5 0.5 over negative 0.86, which is equal to 0.5 over 0.86, because the negative will cancel out. So it gives us a positive answer. At point H, where the angle A of H is 270 degrees, 90, 180, 270 degrees, we'll have the coordinate as 0, negative 1. 0, negative 1. The sine of 270 degrees is given by the y coordinate, which is negative 1. Cosine of 270 degrees is given by the x coordinate, which is 0. Tangent of 270 degrees is given by the sine of 270 over the cosine of 270, which is negative 1 over 0, which gives us infinity. Move to point E. At point E, the angle is 330 degrees. And the coordinates are 0.86, the x, then the y is negative 0.5. Therefore, the sine of 330 degrees is given by the y coordinate, which is negative 0.5. Cosine of 330 degrees is given by the x coordinate, which is positive 0.86. And therefore, the tangent of 330 will be given by negative 0.5 all over positive 0.86, which gives us a negative answer. So, in conclusion, we find that all the angles in the first quadrant, the trigonometric ratios of all the angles in the first quadrant are positive. We have sine is positive, sine is positive, cosine is positive, and the tangent is positive. In the second quadrant, we have all the trigonometry ratios. We have the cosine is negative, the sine is positive, but the tangent, because this is positive over negative, should give us a negative. The tangent is negative. Therefore, in the second quadrant, it is only the cosine. In the second quadrant, it is only the sine that is positive. The cosine is negative and the tangent is negative, because 0.5 divided by negative 0.86 will give us a negative answer. When you go to the third quadrant, in the third quadrant, we have the sine as negative, the cosine as negative, so it is only the tangent that is positive, because we have negative 0.5 divided by negative 0.86, which gives us a positive answer. So in the third quadrant, it is only the tangent that is positive. The sine and the cosine are negative. When we come to the fourth quadrant, in the fourth quadrant, we have the sine is negative, the cosine is positive, and therefore the tangent will be negative, because it will be negative 0.5 divided by 0.866, which is equal to a negative answer. So we conclude that in the fourth quadrant, only the cosine that is positive. All the other trigonometric ratios, that is the sine and the cos and the tangent, are negative. So we can say here all of them are positive. In the second quadrant, it is only the sine that is positive. In the third quadrant, it is only the tangent that is positive. In the fourth quadrant, it is only the cosine that is positive. Use of trigonometric tables. Angles in the first quadrant are angles that are less than 90 degrees. We read directly from the tables. Sine of 30 degrees, you get 0.5. Cosine of 50 degrees, you get positive 0.6428. We read directly from the tables because all of them are positive. Second quadrant, we have only sine that is positive. All the other trigonometric ratios are negative. It is only sine that is positive. Second quadrant, we have the range from 90 degrees is less than 30 degrees, which is less than 180 degrees. Therefore, to read from the tables, we first get the difference between 180 and the angle theta, because this is the maximum. So for the sine theta, we will get sine into bracket 180 degrees minus theta. For the cosine theta, because it is only sine that is positive, it will be negative cosine into bracket 180 degrees minus theta degrees, close the bracket. For the tangent, because still tangent is negative, we will have negative tangent into bracket 180 degrees minus theta degrees, close the bracket. For example, if theta is 120 degrees, we will get that the sine of 120 degrees is equal to sine into bracket 180 degrees minus 120 degrees, which is equal to sine of 60 degrees, which is equal to 0.866. For the cosine of 130 degrees, cosine is negative in the second quadrant. Therefore, it will be negative cosine into bracket 180 minus 130, close the bracket, which is equal to negative cosine 50. 180 minus 130 is 50. Which will give out the answer as negative 0.6428. In the third quadrant, the leg is from 180 degrees to 270 degrees. So it will be 180 degrees is less than theta, theta is less than 270 degrees. In the third quadrant, we previously discussed, in the third quadrant, it is only the tangent that is positive. All the other two trigonometries are negative. Therefore, sine theta will be given by negative sine into bracket theta minus 180 degrees. Note that our baseline is the horizontal axis, that is the x-axis. So we either measure angles up or below the x-axis. This angle in the third quadrant are angles that are below. So they are more than 180 degrees. Therefore, to get the trigonometry ratios, we take the angle, we subtract 180, so that we get the acute angle. So in this case, sine theta will be equal to negative sine into bracket theta minus 180, which will be, when we have an example, sine of 240, we get negative into bracket 240 minus 180 equals to negative sine 60. 240 minus 180 is 60, and that gives us negative 0.866. When you have cosine theta, cosine is negative in the third quadrant, so it will be negative cosine into bracket theta minus 180 degrees. For example, if you have a cosine of 230 degrees, this will be given by negative cosine into bracket 230 degrees minus 180 degrees. Close the bracket. So this is equals to negative cosine of 50. 230 minus 180, we get 50. So negative cosine of 50, which is equal to negative 0.6428. For the tangent, tan theta, in the third quadrant, it is only the tangent that is positive. So we'll have tan theta is equal to tan, positive tan into bracket, theta minus 180, close the bracket. An example of 260 degrees, when theta is 260 degrees, so we'll have tangent of 260 degrees is equal to tangent, positive, into bracket. 260 minus 180, we get 80, which is equal to tangent of 80 degrees, which is equal to 5.6713. In the fourth quadrant, we have the rate as 270 degrees is less than theta, theta is less than 360 degrees. So our maximum angle there is 360. Therefore, sine theta will be equal to negative sine into bracket 360 degrees minus theta. Remember, in the fourth quadrant, it is only the cosine that is positive. So cos theta will be equal to cosine positive into bracket 360 degrees minus theta degrees. Close the bracket. The tangent of theta will be equal to negative tangent into bracket 360 degrees minus theta. Close the bracket. only cosine is positive. The other two are negative. So let theta be equal to 360 degrees. Therefore, sine 330 degrees will be equal to negative sine into bracket 360 minus 330 degrees. Close the bracket. We get negative sine 30. 360 minus 330 is 30. And sine of 30 is 0.5. Therefore, negative sine 30 will be equal to negative 0.5. Cosine of 330 degrees will be given by cosine into bracket 360 minus 330 degrees into bracket. That gives us cosine of 30, which is equal to 0.8660. Tangent of 330 degrees will be equal to negative tangent into bracket 360 minus 330 degrees, which is equal to negative tan 30, which is equal to negative 0.5774. So in conclusion, we have seen that all the angles in the first quadrant, the trigonometry ratios are positive. In the second quadrant, only the sine that is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. Angles greater than 360. In general, if theta is greater than 360 degrees, we tackle it as follows. Sin theta is equal to sine into bracket theta minus 360 degrees times n. Cos theta is equals to cosine into bracket theta minus 360 degrees times n. Tan theta is equal to tangent into bracket theta minus 360 degrees times n, where n is the number of complete revolutions. And one complete revolution is 360 degrees. Examples: 910 degrees, 1100 degrees. Sine of 990 degrees will be equal to the sine into bracket 910 degrees minus into bracket 360 times 2, where 2 is the number of revolutions. There are 2 revolutions. So this is equal to sine 910 minus 720. 360 times 2 is 720. That gives us now 910 minus 720, we get 190 degrees. Sine of 190 degrees, 190 is in the third quadrant. 190 is in the third quadrant. And in the third quadrant, it is only the tangent that is positive. So we'll see that now 190, it is greater than 180. And in the third quadrant, we always say theta minus 180. So it will be sine into bracket 190 minus 180, which is equal to 10 degrees. It will now be negative sine 10 degrees, which is equal to negative 0.1736. Why negative? Because 190 is in the third quadrant, and in the third quadrant is only tangent that is positive. Therefore, the sign in that quadrant will be negative. For the cosine of 910, to give us the cosine of 190, negative cosine 10 degrees. Why? Still, because it is only the tangent that is positive, the cosine will be negative. So it will be negative 0.9848. Tangent of 980 degrees will give us the tangent of 190 degrees. And because 190 degrees is in that quadrant, tangent is positive in that quadrant, so it will be positive tan 10 degrees, which is equal to positive 0.1763. The next example is 1100, so we get sine of 1100 degrees. It will be equal to the sine into bracket 11 minus 36 times 3. There are 3 complete terms, and 3 revolutions gives us 1080. So it will be sine into bracket 1100 minus 1080, which is equal to sine of 20 degrees. 20 degrees is in the first quadrant. So all of them are positive. Therefore, the sine of 20 degrees will be equals to positive 0.3420. Then the cosine of 20 will be given by 0.9396. And the tangent of 20 will be given by 0.3640. Note it is at the second juncture, that is after subtracting here, the angle that we get here is the one that will be is the one that is guiding us. We got 190 here. After subtracting, we got 190. So 190, that quadrant. So we are guided. That quadrant only the tangent that is positive. That is why this was negative, this negative, and this one negative. The other one negative. This one of the cosine negative, the sine negative, and the tangent positive. In the next case, our angle after we subtract the number of rotation is 20 degrees. 20 degrees is in the first quadrant, and all the trigonometry ratios are positive. That is why we get sine of 20 as positive, cosine positive, and tangent positive. Angles less than negative 360 degrees. In general, if theta is less than negative 360 degrees, we get the trigonometric ratios as follows. Sine theta will be given by sine into bracket theta plus 360 degrees multiplied by n. Cos theta will be cosine into bracket theta plus 360 degrees times number of complete revolutions, and tan theta will be given by tan into bracket theta plus 360 degrees n. Close the bracket, where n is the number of complete revolutions. Note that the negative here means now we are measuring the angle in a clockwise direction. So we are starting from 0, we move this way, one complete turn, one complete revolution, one complete revolution. So the negative is, so that angle is less than 360 because it is more than one complete turn. So if you start from 0, you make a complete revolution, you go back to 0, that angle is negative 360 degrees. So any other angle that is less than negative 360 degrees will be below 0 here. It could be 361, negative 361, which will be in the fourth quadrant, and it will be less than 360. For example, if you have negative 1000, it will give us one complete turn 360, another complete turn negative 720, another complete turn like that. So it will be more than 2 complete turns. So sine of into bracket 1000 degrees will be given by sine into bracket 1000 degrees plus into bracket 360 times 2, which is 720. When you add, we get negative 280. Now we are at that negative 280. So where is that angle? It is in which quadrant? Starting from 0 here, 0, 360 degrees, negative direction, negative angle means clockwise direction. So from here to here we have negative 90, from here to here we have negative 180, negative 270, so negative 280 is in the first quadrant. And in the first quadrant, all the trigonometry ratios are positive. So how do we get the acute angle here? To get the acute angle, we say sine to bracket negative 280, we add 360. We are adding 360 times the number of revolutions. The number of revolutions here are, it is still within the one, it is still within the first revolution. It is not beyond the first revolution. So negative 280 degrees plus 360. So we get 80 degrees. So we are interested now, we get sine of 80 degrees. Our acute angle here is 80 degrees. Sine of 80 is 0.9848. When we come to the cosine, cosine of 80 degrees will be 0.1737. And the tangent of 180 degrees will be given by 5.671. All of them are positive because -1, -280 is in the first quadrant. You asked to solve for x degrees, and you are given these examples. Sine of x degrees equals 0.5, sine of x degrees equals 0.8660, cosine of x is equal to 0.6428, tan of x is equal to 1.4282. To get x, you go to a calculator, look for the trigonometric ratio button, double press the button to change the command to inverse. After double pressing, it will give you sine inverse. Then you place 0.5. It will give you x. And our x will be 30 degrees. You do the same for part B. Trigonometric ratio button. You double press to change the command. It will give you sine inverse. Then you place 0.8660. The angle will be given as 60 degrees. For the cosine, you go to the trigonometric ratio button that is written cosine. You double press to change the command to give you cosine inverse. Then you key in 0.6428 to give you 50 degrees. For the tangent, the same. You go to the calculator, the button, trigonometric ratio button written tangent. You double press to give you the tan inverse. Then after it gives you the tan inverse, you key in 1.4282, and it will give you an angle of 55 degrees. We are now turning to the radian measure. 1 radian is an angle subtended at the center of the circle by an arc length equal to the radius. 1 radian denoted by a letter C1 and letter C up there is equal to 1 radian is an angle subtended by an arc length. In our case, arc length AB equal to the radius of the circle. We denote theta radians as theta radians. The circumference of the circle is 2 pi r. It is pi times the diameter. The diameter is 2r. That's why you see 2 pi r. Arc length of r, that is arc length equal to the radius, subtend an angle of 1 radian at the center. Therefore, angle subtended by the circumference at the center is 2 pi r divided by r. Because the circumference is 2 pi r, then you divide by the r, which is now the part of the circumference, to give us 2 pi radians. But in degrees, it is 360 degrees. The angle at the center is 360 degrees, and that angle that is 360 degrees is equal to 2 pi radians. Therefore, 2 pi radians equals 360 degrees. Take pi as 3.142. Number 1 radian will be given by 360 divided by 2 pi, which is 57.29 degrees. 1 radian is equal to 57.29 degrees. Because we have taken the total number of degrees as 360, we are dividing by the total number of radians at the center. So we get 57.29 degrees. Number 2, we know 360 degrees is equal to pi radian. Therefore, 1 degree will be given by, we divide by 360 on both sides, and when we divide by 360 by 280, we'll get pi over 80 radian. So 1 degree is equals to pi over 180 radians. 360 degrees is equal to 2 pi radian. Therefore, we can divide by 2 on both sides and say 180 degrees is equal to pi radian. Example, convert to radians. 60 degrees and 405 degrees. Solution, we know 1 degree is equal to pi all over 180 radians. What about 60 degrees? It will be equals to pi over 180 times 60 degrees radians. It will give us, divided by 6163, it will give us pi over 3 radians. 405 degrees will be equals to pi all over 180 times 405 into bracket radians. So this gives us 9 over 4 pi radians. Then he has to convert to degrees. Convert to degrees. 1.4 radians and 2 over 5 pi radians. 1 radian is equals to 180 over pi degrees. Therefore, 1.4 radians will be equals to 1 over 80, 180 all over pi times 1.4, which will give us 80.21 degrees. 2 over 5 pi radians will give us in degrees 180 all over pi times 2 all over 5 pi. These are in degrees. By 5, 1, by 5, 36. 36 times 2 will get 72 degrees because the pi and pi will cancel out. That's simply how we convert either to radians or to degrees using the basic principles from the circle. We now move to simple trigonometric graphs. The graph of y is equal to sine theta. We have an interval of 0 degrees is less or equal to theta. Theta is less or equal to 360 degrees. We make an interval of 30 degrees. So theta, we start from 0, 30, 60, 90, up to 360. Our interval is from 0 to 360 degrees. For the purpose of graphing, we have approximated the value of sine theta to 2 decimal places for the purposes of drawing the graph. So we'll have the vertical axis or the horizontal, we have the horizontal axis as theta degrees and the vertical axis as the sine theta. So when you have 0 degrees, the sine is 0. When you have 30 degrees, the sine is 0.5. 60 degrees, sine is 0.87. And when you have 90, we have the sine as 1. Or all the way up to 360, where sine theta is equal to 0. We need to use the graph to solve given questions. I will consider 2 or 3 examples to solve using our graph. The question we have here is, use the graph to solve the following. A, 6 sine theta is equal to 5. B, 2 sine theta plus 1 is equal to 0. C, 25 sine theta minus 4 is equal to 0. And D, 8 sine theta plus 7 is equal to 0. We go to solution. First of all, you simplify the equation. We take 5 to the other, we take 6 to the other side. So it will be sine theta is equal to 5 divided by 6, which is equal to 0.833. Number B, we take 1 to the other side to be negative 1. Then we divide by 2. So that sine theta is equal to negative 1 divided by 2 is equal to negative 0.5. When you go to C, we are given 25 sine theta minus 4 equals 0. So you take 4 to the other side, it becomes positive. then divide by 25. Sine theta is equals to 4 divided by 25, which is equal to 0.16. Then number D, we take 7 to the other side, it will be negative 7. Then we divide by 8. So sine theta is equal to negative 7 divided by 8, which is equal to negative 0.88. Now we need to use our graph to solve that. Sine theta is equal to 0.833. So we get the graph. This is 0.5, this is 0.75. So 0.833 is below 0.867. So you use a ruler, you draw a line, a straight line using a ruler. Then where that line cuts the curve, we go to the horizontal axis and you read the value of theta. The first value of theta here is 54 degrees. Then the second value of theta here is 126. So the solution for theta using the graph is theta is equal to 54 degrees and 126 degrees. We go to B, and theta is equal to negative 0.5. So negative 0.5 is here. You draw horizontal line. Then from the horizontal axis at that point, we get 210 degrees and 330 degrees. Where the vertical line from 210 to the horizontal line at negative 0.5, that line, horizontal line, where the two lines meet, we read the value of theta. So you get 210 and 330. For number C, we have sine theta is equal to 0.16. 0.16. Up to here, we have 0.25. So 0.16 is slightly below. So you draw a line, that line cuts the curve at that point and at that point. So you move down using a ruler, you read the value of x here, the value of theta here, and the value of theta here. So you get 9 degrees and 171 degrees. For number D, sine theta is equal to negative 0.88. Up to here 0.7, negative 0.75, negative 1. So 0.88 is nearer to the negative 1. So you draw a horizontal line. Where the line cuts the curve, you read the angle. Up there it's 241, and the other angle here 299. That's how we get theta is equal to 241 and 299. So a ruler is very important here because you must draw a horizontal line using a ruler and the value of sine theta given. Here we have the graph of y is equals to cos theta. For the range, 0 degrees is less than or equal to theta. Theta is less or equal to 360. We make a table using an interval of 30 degrees for the angle. And for the cosine theta, we approximate to 2 decimal places for the purpose of the graph. Then we have the graph of y is equals to cos theta, where we have the horizontal axis, we have the theta, the vertical axis, we have the cosine of theta. We need to use the graph to solve various questions, like the following examples. We asked to use the graph of y is equals to cos theta for the rate 0 degrees is less or equal to theta, less or equal to 360 degrees, to solve the following. Cosine of theta is equal to 0.25, cos theta is equal to 0.84, cos theta is equal to negative 0.62, and cos theta is equal to negative 0.9. The first one, cosine theta is equal to 0.25. You get a ruler where we have this is 0.5, this is 0.25. You draw a horizontal line using a ruler. Where the ruler cuts the curve, you move down, you read the value. This is 75, and the other value is 285. For B, 0.84. 0.84 is slightly below 0.87 and is above 0.75. So you draw a horizontal line. Where the line cuts the curve, you go down, you read the value, the two values. So the first value is 33 and the other one is 27 degrees. Then move to the next part C, negative 6.02. This is negative 0.5, so negative 6.2 is slightly below. You draw a horizontal line. Where the line cuts the curve, you go to the horizontal axis of theta, you read the value here as 127 and the other value here as 233 degrees. Finally, cos theta is equal to negative 0.9. Negative 0.9 is closer to negative 1. So you draw a horizontal line. Where the line cuts the curve, you go up to the horizontal theta axis. You read the value as 155, and then the other value here as 205 degrees. And that's how basically you read from the curve to solve the given question. Here we have the graph of y is equal to tan theta. For the rate, theta is less, 0 degrees is less than theta. Theta is less than 360 degrees. When you have theta is 0, then you have the tan of 0 as 0. When 30, you have that one 0.58. When 60, 1.73. And when it is 90, we have that one as infinity. The tangent of 90 is not defined. Now we go to 120. At 180, you have 0. Then again at 270, the tangent of 270 is not defined because we know that sine is equals to tangent is equal to sine over cosine, and here we have negative 1 over 0, which is infinity, and here we have 1 over 0, which is infinity. So at 90 we draw a vertical line to indicate that the curve cannot cross that line because it's not defined. And at 170, we drew that broken red line, vertical line, to indicate that the curve cannot cross that line. We call these two lines asymptotes because the curve cannot be defined. The tangent of an angle cannot be defined. These two lines are called asymptotes. We can now use the graph to solve various given questions, like the following. Use the graph of y is equal to tan theta for the range 0 degrees is less or equal to theta, theta is less or equal to 360 to solve the following. A, tangent of 125 degrees. And B, you find theta given that 3 tan theta minus 6 is equal to 0. Take 6 to the side, and then you divide by 3. So tan theta is equal to 2. We go to the graph. We want the tangent of 125 degrees. So we go to where 125 degrees is. Use a ruler, you drop a line to the curve. Then move horizontal to the vertical axis and read the value of tan theta. When you have theta as 125, and you get that value is negative 1.25. For number B, tan theta is equal to 2. This is 2. So you draw a horizontal line. When the line cuts the curve, you go down, you read the value. You go down, you read the value. And you get that the two values are 63 and 243 degrees. The sine rule. Consider any triangle ABC with the sides B, A, and C. Drop a perpendicular from A to meet BC at D. Then you drop another perpendicular from B to meet AC at K. and the third perpendicular from C, you draw perpendicular from C to meet AB at E. So you have three perpendicular lines. Using triangle ADC, we get that sine C is equal to opposite over hypotenuse. So it should be AD over B. Therefore, AD is equal to B sine C. From that triangle ADC, we can get the area of triangle ABC by using the half base times height. Our base is A. So it will be a half A, then times our height, which is AD, which is B sine C. So we'll have a half AB sine C. So that gives us our first equation. Then, number 2, using triangle CBE, we'll get that sine B is equal to opposite, which is CE, all over the hypotenuse, which is A. In that case, our CE is equal to A times sine B. Using the triangle CBE, we can get the area of triangle ABC by getting the half base times height. So our base is C. So it will be a half C times the height, which is our CE, which is A sine B. So you get the area of that triangle as a half CA sine B. That gives us our second equation. Number 3, we can use triangle ABK. When using triangle ABK, we can get the sine of angle A, which is opposite of hypotenuse. So sine A will be equal to BK all over C. Therefore, BK is equal to C times sine A. Using that triangle ABK, we cannot get the area of triangle ABC by using the half base times 8. So it will be a half B times the height, which is BK, and BK is C sine A. So we get a half BC sine A. That's the third equation. Combining equation 1 and 2, that is a half AB sine C and half AC sine B, we can cancel out the half, and then we are left with B sine C is equal to C sine B, and dividing by sine C on both sides and sine B on both sides, we have B over sine C is equal to C all over sine C. That gives us the fourth equation. Combine equation 2 and 3. So we'll have a half AC sine B is equal to half BC sine A. This a half C will cancel out. So we'll be left with the C will cancel with the C, the 2 and 2, the half and the half will cancel. So we'll be left with A sine B is equal to B sine A. From that, we can divide both sides by sine B. So we'll have B over sine B. Divide both sides by sine A, we'll have A over sine A. We get the fifth equation. A over sine A is equal to B over sine B. That is our fifth equation. Combining equation 4 and 5, that is this 4 and this 5, we'll get that A over sine A is equal to B over sine B is equal to C over sine C, which is our sine law. Alternatively, we can use triangle ABC, which is a circumscribed triangle with a circle center. We can draw a line through the center to meet the circumference of the circle at C prime. That line BC prime, it is actually a diameter because we have R and another R, because this is the center of the circle. Angles subtended by the same arc on the circumference are equal. Therefore, angle AC prime B and ACB are equal. They are subtended by the same arc AB. Arc AB to the circumference, then arc AB to the circumference, we get this angle is equal to this angle. That is, this angle is equal to this angle, because the two angles are subtended by the same arc on the circumference. Therefore, the two triangles are equal. Therefore, the two angles are equal. Angle ACB and angle AC prime B. Having that now in mind, we can get the sine of C prime. The sine of this C prime, this angle, will be equal to the opposite, which is AB, over the hypotenuse, which is BC. Note that our angle AA is 90 degrees, angle C is 90 degrees, because that the two angles are subtended by the diameter on the circumference. So the two are 90 degrees. So using the right angle triangle ABC prime, we'll have that sine of angle C prime is equal to opposite AB over hypotenuse, which is BC prime. This implies that BC prime is equal to AB all over sine C prime. BC prime is equal to AB all over sine C prime. But BC prime is the diameter, which is 2r. BC prime is the diameter, so you have 2r. Therefore, our BC prime, which is the diameter, which is 2r, is equal to AB all over sine C prime, which is equal to AB over sine C, and it is also equal to C over sine C. Our AB is C. Our AB is the length C. So it will be C all over sine C. Therefore, 2r is equal to C over sine C. If it is equal to C over sine C, it will also be equal to B over sine B and A over sine A. That is, the diameter 2r is equal to the sine rule, the cosine rule. Draw any triangle PQR. Draw a perpendicular from P to meet QR at D. QD, let QD be equal to X, such that now our DR will be P minus X. The whole length of QR is P. PR is Q and PQ is R. So we have, if QD is X, then DR is P minus X. From triangle PQR, we have that PD squared will be equal to Q squared minus PX squared. That gives us our first equation. Using triangle PQD will have that PD squared, this perpendicular PD squared will be equal to R squared minus X squared. That is the hypotenuse squared minus the base squared, because it's the height. R squared minus X squared. Therefore, our Q squared minus PX squared, which is PD squared, is equal to the other PD squared, R squared minus X squared. Opening the bracket here, we'll have Q squared minus P squared minus 2XP plus X squared. This is equal to R squared minus X squared. Removing the bracket now, we'll have Q squared minus P squared plus 2XP minus X squared is equal to R squared minus X squared. Move further, Q squared now. You'll be left with Q squared on one side, you take the less to the other side. So we'll have Q squared is equal to, when this one crosses the equal sign, it becomes plus, this one becomes minus, this one becomes plus. Then plus R squared minus X squared. Here, the X squared minus X squared cancels. So we are left with, that one disappears, so we are left with P squared plus R squared minus 2XP. That is what we have, minus 2XP. But we know, cosine of angle Q will be given by the opposite, will be given by the adjacent side over the hypotenuse. So cosine of Q will be given by R over X. But cos theta is equal to X over R. Cosine of theta is equal to adjacent over hypotenuse, so it is X over R. Therefore, our X, cross multiplying by R, our X is equal to R cos theta. Where we have X now, we substitute with R cos theta. Therefore, our Q squared becomes P squared plus R squared minus 2P. Where there was X, we substitute R cos theta. Get R cos theta. It follows that when we have R squared, it will be equal to P squared plus Q squared minus 2PQ cosine of R. And when you have P squared on this side, having P squared as a subject, we'll have Q squared plus R squared is equal to Q2RQ cosine of P. And this is the sine rule. Given the angle, given the side, you can substitute for the other. Example, a triangle ABC is such that AB is 10 centimeters, BC is 12 centimeters, and angle ABC is 100 degrees. Calculate the length of ABC, the length of AC, and the diameter of the circumcircle. We make a rough sketch of that triangle. We will have our AB is 10, BC is 12, and angle ABC is 100 degrees. The opposite side of the angle B we name it as small letter b. Using the cosine, the unknown is b. So b squared, you must always note that the b squared, then at the end you have the cosine over 100. So the b squared will be equals to the given side, that is 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 100. B squared 100 plus 144 minus, into bracket we have negative 41.64, which is now 2 times 10 times 12, then multiplied by the cosine of 100. B squared is equal to 44 plus 41 point. Negative and negative becomes positive, so we'll have 41.664. When you add, you get 25.664. That is our B squared. Therefore, our B is the square root of this, which is 16.90 centimeters. Therefore, our AC is equal to 16.90 centimeters. Number 2, we want to find the diameter of the circumcircle. The diameter is the 2r, which is equal to the sine rule. And the sine rule means B over sine B. So 2r is equal to B, which is 16.90 all over sine B. 16.90. Sine of 100 is 0.9848. When you divide, you get 17.61. 2r is equal to 17.16 centimeters. Therefore, the diameter is equal to 17.16 centimeters. Example 2. The bearing of Kisumu from Thika is 285 degrees. The two towns are 400 kilometers apart on a straight line. Embu is 140 kilometers from Thika on a bearing of 25 degrees. Question: find the distance on a straight line between Kisumu and Embu. What is the bearing of Kisumu from Embu? Solution: you make a rough sketch diagram. Start from Thika. We have our north. So Kisumu is 285. So from north you measure an angle of 285. Then you draw a straight line. So Kisumu is on that direction. Embu is on a bearing of 25 from Thika. So from north 25 degrees, you draw that line. So that gives you the direction of Embu, 140 kilometers. We want to find the distance between Kisumu and Embu. So call that distance T. That distance T, we have 140 and we have 400. So we need to look for this angle. That angle from here to here is 285. So what remains now is 360 minus 285. 360 minus 285, then you add 25. So that gives us 100 degrees. So the angle is 100 degrees. Therefore, when we go to the cosine rule, we want t. So t squared will be equals to 140 squared plus 400 squared minus into bracket 2 times 400 times 140, then the cosine of 100. 400 squared is 16,000. This is 19,600. 2 times 400 is 140. That gives 112,000 times now the cosine of 100, which is negative 0.1736. When you open that bracket, you get negative 194.43.2. Negative and negative gives you a positive. So we'll have 179,600 plus 194.43.2. That gives us 1990.43.2 as our t squared. So when you find the square root, you get that t is 446.1, that distance, centimeters. So that gives us our distance, same distance between Kisumu and Embu as 446.1 kilometers. What is the bearing of Kisumu? T squared is equals to 400 squared plus 140 squared minus into bracket 2 times 400 times 140 cosine of 100. 400 squared is 160,000. 140 squared is 19600 minus into bracket 400 times 140 times 2 is 112,000 times now the cosine of 100, which is negative 0.1736. When you multiply this one, you get a negative. So that negative, when you open the bracket, because there's another negative, it becomes positive. So you have positive 19,443.2. When you add that one to 179,600, you get 199,043.2. When you get the square root, you find that t is equals to 446.1 kilometers. The bearing of Kisumu from Embu. We want the bearing of Kisumu from Embu. So it will be all these angles. The bearing of what is the bearing of Kisumu from Embu? So we want this. We want that t over sine 100. T over sine 100 is the same as 400 over sine e. This angle over sine e. T times sine e is equals to 400 times sine 100. So sine e is equals to 400 times 0.948, which is the sine of 100, divided by our t, which is 446.0. Sine e will be equals to this times this divided by this will be 0.8832. Therefore, angle E will be given by the sine inverse of 0.8832, and the angle is 62 degrees. Therefore, angle KET, this angle is 62 degrees. The bearing of Kisumu from Embu, all these angles, it will be 25 plus 180. This is a horizontal line. Therefore, from here to here, it is 180. So 25 plus 180, then plus angle KET, which is 62, to give us 267